final bits. Okay. As Ceci said, social robotics for assessing and promoting mental well-being is the main focus of my talk today. So talking about mental well-being probably is familiar to all of us being in academia, because it is one of the issues commonly highlighted being a PhD student or academic, particularly in high demanding and competitive environments. But obviously not just academia. Many different organizations around the world have highlighted actually increase in mental health conditions due to various things, and COVID-19 being one of those as well in the last couple of years. So in general, the problem is actually people who require access to the assessment, but also to relevant interventions, and people who eventually can get such an access. So there's a big gap between those. So then the World Health Organization really listed among its goals the promotion of mental well-being, prevention of mental issues, and various efforts to increase access to quality mental health care. Of course, there could be different solutions to this. Our approach in my group is to investigate whether we can use social robots, because social robots can actually constitute as engaging and novel tools to help assess and promote mental well-being, because they can also offer, affordable and accessible practices and services. And what we mean by this is, unlike human beings, robots don't get tired. So they actually can be also consistently programmed or learn to give and provide similar practices, unlike a human that might need caffeine, or they need to have, lunch, dinner, or depending on their own life, they might be undergoing through their own issues and so on. So this is our main motivation. Then in terms of what we mean by well-being coaching, we are here inspired by how humans do well-being coaching. So there are different styles, of course, and I have actually tried some of these myself to really have a sense throughout the years. For instance, you might have heard mindfulness or meditation. This is now quite prominently known in the West as well as the East, where it's originally coming from. There are other types, also, for instance, positive psychology type of exercises, or further therapy style like cognitive behavioral therapy and so on. And in all of these cases, when it's delivered by various humans, so it could be like life coaching or actual therapists, clinicians, there are different goals, again, depending on where the person is within that continuum of well-being, because even that is not binary. So then the goal is to really increase the person's hope, their positive attitudes, their goal striving, and overall well-being. So then there have been various studies in terms of how social robots can be used as tools for well-being. So the literature in terms of using them for physical well-being is actually a bit older, let's say. But when it comes to using them for mental well-being, we sort of started around the same time as a team in MIT, without obviously knowing each other's efforts. But I think our archive papers appeared around the same time in 2020. So for instance, they were using a Jibo robotic platform to deliver positive psychology interventions. And we started with my 5-year project as a fellowship project focusing on mental well-being as well around the same time. And since then, actually, the number of studies focusing on the different aspects of this have dramatically increased, also due to the need for such practices as well. And when we look at those studies, what we see, and here I sort of use the term research landscape, is we can sort of categorize it along multiple dimensions. So study setting being one. So usually trying to do things in the lab enables control, and then varying certain aspects to be able to take those studies into the wild and ultimately real-world deployment. In terms of autonomy, some studies do Wizard of Oz or teleoperating the robots, and I'll explain those with examples. But the ultimate goal will be those robots being not only autonomous, but also adaptive and personalizing to the user. In terms of form, there could be mechanical looking, but all the way from mechanical within that spectrum to toy-like, animal looking, humanoid looking, or some studies even comparing those different forms. And then in terms of study length or frequency, you'll see there could be one-off studies, but then trying to do multi-session. But ultimately, the goal is to engage the users in longitudinal interactions, just like human therapists would do. And in terms of involvement, different studies would involve different people. But ultimately, the goal is to involve different stakeholders. So not only potential users, but also human coaches to learn from them, and to do this iteratively and in a user-centered manner. So as I give examples of our different studies, I'll try to use this research landscape and try to position it where it would actually fit. So as I mentioned, we started focusing on social robots for mental well-being in 2019 with a fellowship project that I got called Adaptive Robotic Emotional Intelligence for Well-being. And really, our vision is to develop autonomous well-being coaches. So everything you've seen on the table that I was showing you is really our vision to really develop these autonomous, but at the same time, adaptive and personalized robotic well-being coaches that actually could do embodied multimodal interactions in terms of sensing, but also responding with their own behavior. And to be able to then do these sort of sessions or practices in the long term. And in terms of approach, we really do this iterative design approach. So we started our studies with human experience coaches and users. And then from there, we really learn things, we iterate, we modify the design. And then, as I'll show, we have run different studies based on our understandings and insights we gathered from those. So starting with the first one, so initially we started with teleoperated robot coaching because we really wanted to involve experienced human coaches. And we also started with mindfulness practices. So we involved a mindfulness coach that has experience over 20 years in conducting this in group sort of settings. And we wanted to do it in the lab so that we could control things. So when it comes to teleoperation or telepresence robotics, in case you might not familiar with robotics itself, what it means is, so the robot is not autonomous. There's actually an operator that operates the robot using various interfaces. Here I show an example. This is, for instance, an interesting case where such robots could be even programmed by various interfaces, even by paralyzed people. So they could be used because the idea would be to be physically there via a robot where you cannot be for whatever the reason is. So this is an example where such a trial was done in a cafe in Tokyo. So there is a lot of potential actually using telepresence robotics. In our case, we conducted a 5-week study where we had 2 groups of people receiving mindfulness practices. As I said, from an experienced coach. So to be able to do this teleoperation aspect, we actually developed a pipeline, a framework with pose, vision, and audio pipelines. So during the sessions, we would have human coach sessions where the human just delivers the normal mindfulness practice multimodally to a group of people. But when they're teleoperating, so that would be the robotic coach mode, the human coach would not be located with the actual people, so it's located remotely, and then would teleoperate the robot with the help of these 3 pipelines. So the pose replication pipeline would relay the estimated pose of the human coach to the robot in real time, as well as the video and audio pipelines to enable perception action loops where a human coach can see and also talk to the participants through the robot by wearing this virtual headset where, we relay those things on the headset. And in terms of results, what we see is during the interaction with the robot coach, we see low ratings were given to the aspects of animacy and anthropomorphism, while people gave high ratings for likability. We were using a Pepper robot, so it's quite likable, and therefore this is not surprising. And also perceived intelligence was given rated as high, and this is due to the robot being teleoperated by the human coach. Then we also see that there are significant increases in the ratings of robot motion and conversation in time, suggesting actually participants initially might be experiencing what we call novelty effect, which means they're not used to doing such a thing with a robot. So the first thing they might be just experiencing this aspect of novelty effect, like not knowing what to expect, might be surprised. And then in time, actually, we see these things settling. So participants need time to understand the capabilities of the robot to improve the perception towards these aspects. We also compared the ratings on the scales of anxious, relaxed, and agitated calm before and after each session. And we can see that each session promoted significantly positive mood among the participants for both human and robot coach sessions. Interestingly, we observed less variability for the robot coach sessions or ratings. And this is difficult to attribute to a specific reason, but could be due to the fact that human-human interactions usually are prone to variations in nonverbal behaviors and expressivity, as I was saying, depending on whether we had enough caffeine or whether we have our own problems and so on. But actually operating or doing this via robots, those appearance aspects are diminished. So things appear a bit more stable. But again, this would require further and specific investigation. In terms of key takeaways, we also looked at correlations between the self-reported personality and some of these findings. And we found an association between the participants' conscientiousness and neuroticism scores and their perception ratings for these different aspects of robot coaching sessions. For instance, there's a negative association between conscientiousness and robot motion, which indicates people who are high in terms of conscientiousness dimension expect the robot to move more naturally than it currently does. And then people with high neuroticism also give low ratings on the questions related to how much they enjoy the sessions. So overall, this just suggests that people with different personalities might have different expectations. Therefore, robotic well-being coaching might benefit from this aspect of adaptation and personalization. So learning from this initial study, then what we wanted to do was we wanted to investigate a bit deeper in terms of the needs and requirements of participants or in general potential users for such robotic coaching practices. And we also wanted to know whether human coaches would actually think that robots would be able to deliver such practices, and in particular, what sort of practices would be more appropriate for robots to deliver. So we really wanted to understand this a bit more, and we focused on participatory design. So this is quite well known in studies like interaction design or human-centered computing. It involves relevant stakeholders in the design process as co-designers, and the aim is to really get these multiple perspectives from different stakeholders, and also with the goal of enhancing acceptance and long-term adherence, in our case, to a robotic coach. So for this, we focused on prospective users and different well-being coaches. So for instance, for well-being coaching, we had mindfulness coach, solution-focused coach, and someone who does life coaching. So we interviewed prospective users and those instructors as well, and you can see the structure actually on the right-hand side. So we had one-to-one interviews. This is actually was all taken during COVID. So a lot of this was done online due to all the restrictions and limitations we had in the UK. So they were provided with pictures of robots, and they were asked what the robot coach should look like, could do, what sort of advantages and disadvantages they see, and so on. So both in terms of interviews, and some of these were brought actually what we learned from the interviews to the group discussions, so very rich qualitative data. Here's an example of how this was run using Miro. For instance, we can see what really would mean in terms of participatory design as a focus group discussion with post-it notes that had certain themes collected from the pre-group discussion interviews. We also have these voting dots as well, for instance, in terms of form of the robot, and you can see on the right-hand side different forms of robots that were being discussed. And then using the recordings and transcriptions, we conducted a thematic analysis. And we found 9 major themes. won't be going through all of them, but you can see basically that robot capabilities is a major one. And then we have robot advantages and disadvantages, features, robot-led well-being practice, the expectations of users, and so on. So in terms of results, we found quite interesting in-depth results. So there were lots of discussions on the role of robot and how it could work together with the human. And in terms of robot form preferences, for instance, it varied, and some participants and coaches preferred a more human-looking robot or humanoid robot, whereas others focused on more abstract appearances. And you can see some of the quotes from different participants as well. In terms of takeaways, we actually saw that participants were quite receptive to evidence from previous studies. So you can see here in terms of their attitudes before they took part in the session and after they took part. And you see after they took part in these interviews and discussions, their opinions about robots actually changed. So they are quite receptive to evidence from studies indicating robots could help improve the well-being. Also, coaches thought that the robot could well perform certain practices, so they were not really opposed to it because they believed it could really give this sense of presence to the human user, having this embodiment and form. So all of these provided some motivation for us to focus on creating autonomous robot coaches, but also to formalize some of the guidelines and recommendations as to how this should be done. So as a next step, we actually wanted to start focusing to one-off sessions. So instead of running longitudinal studies, but also bringing more these autonomous aspects and the affective sensing as well for adaptation, since adaptation was one of the key things. And so we focus on continual learning for effective robotics, and I applied it specifically for this proof of concept for well-being practices. So here I'll touch a bit on these affective aspects that is a major theme in my group, and some students or postdocs focus specifically on affective computing, sensing, developing algorithms for this. But affective robotics would imply robots that are able to sense some of these things that matter to humans, just like what we mean by emotional intelligence, right? So the social cues, affective cues, being able to sense those, but also at the same time being able to reproduce or create some of these on their behavior end. And this is really important because currently the robots are being tested for all of these different environments like healthcare, restaurant settings, elderly care, or even as companions at home. And all of these aspects require them to have this affective or emotional intelligence to varying degrees. And the main thing that is important is this need for adaptation. I'll be emphasizing it throughout my talk. So usually starting with the perception and behavior model out of the box when the robots arrive, they don't really have this adaptation capability. So if you buy from the prototypical companies, the current abilities of these robots, particularly for social aspects, is very limited. But we would like them to learn to interact and adapt with users during interactions, and extend this, also apply this learning to other users, different user groups, and throughout their lifetime. But that's not easy, right? So to do this with traditional machine learning would be quite difficult because, this would be like relying on models trained and fine-tuned in isolation on large benchmark data sets that are not really realistic. If you take them, if they take robots to certain settings, this wouldn't really be useful at all, and would require sort of a costly process of relearning and adaptation. So instead, continual learning enables this aspect of incremental integration of knowledge in models with sequentially made available data. So we don't need to rely on having all the data in the beginning ahead of time. So the models are also highly sensitive to changes in the data conditions. So they would adapt with new information without forgetting the old one. So the continual learning algorithm would adapt the current model by using the newly acquired data about a task along with the past experience, updating both the model and its experience in the process. We discussed this in detail in our IEEE Roman paper, specifically proposing it for effective robotics and what it would mean. I'm not going to go into details, but if you're interested, you can take a look at this paper. Instead, here I'm showing as a framework how we incorporated it in terms of this closed loop interaction for human-robot well-being coaching. So you see that we have the user sensing aspects focusing on detecting the face and also what they say. And then on the face, we have this modular framework for different aspects, but on the face is where we focus on continual learning and trying to adapt things. I'll go a bit more into detail on this one. Speech at that stage was quite basic. We ran this study in 21. But the idea was to actually have sort of keyword level understanding, to be able to have this dialogue manager, make sure that the robot responds in accordance and also makes decisions to be able to produce a relevant behavior. So opening up a little bit more this continual learning aspect. So this was in another work we proposed in 2020, a novel continual learning framework for facial expression recognition. And it relies on these hierarchical neural memories to balance novel learning with preservation of past knowledge at the same time. And here we propose this adversarial learning for imagination. So this is actually quite a sort of potent tool to simulate person-specific data, and it does help improving facial expression recognition. Then in terms of study, so we have this framework in terms of various positive psychology exercises. It focuses on things like impactful things that they feel grateful for, accomplishments. And then we have these 3 conditions. In the first one, it's static and scripted interaction. So the robot doesn't actually do any affect sensing or adaptation. In the second one, it does affect-based adaptation, but doesn't personalize. So just uses generic affect models. Whereas in the third one, it uses continual learning to try to actually do this person-specific sensing and based on this adaptation. So in terms of results, if you're not familiar with human-robot interaction community, usually we look at this self-reported perception and scores in terms of very specific questionnaires that are commonly used in the field. And you see some of these called Godspeed, Rosas, and so on. In general, what we see is in terms of anthropomorphism, animacy, and likability, for instance, of the robot, that the scripted version was really not, voted or ranked well at all. So actually, significantly, the 2 conditions that rely on sensing affect and further with continual learning adapting, they're significantly better for this. And in terms of warmth as well, when we look at Rosas, there again, we see people preferring or even being able to identify the continual learning adaptive condition. And we also had customized questions. So for instance, one of them relates to robot understood how I felt. So even there we see that continual learning comes as the preferred mode in terms of how the robot can actually perceive them and adapt its behavior. So in terms of key takeaways, here we use the unimodal affect perception based on face only, but obviously if it can be done in a multimodal manner, it would be much more powerful. And also this was a one-off study, meaning people only did this one session, although they had multiple things to talk about with the robot. They did not come on a weekly basis. So the potential of continual learning should actually be investigated in that respect as well. There are challenges for continual learning, so it's not like a solution or golden solution for everything. So we cover these aspects in our paper. Just to give one example, for instance, for continual learning to actually properly to adapt and learn from a human, initially it doesn't have data about a person, right? So initially it wouldn't be doing very well because it needs to acquire data about that person and then start, the model sort of learns and then starts adapting to that specific person. So there are such challenges we identified. We also propose solutions. So again, if this is something of interest to you, please take a look at this specific paper. So now moving on to another study. So we sort of So all of these different aspects, now we wanted to start taking these robots out from the lab to the real world. And one of them was this workplace study. I mean, as we know, work can be quite motivational and inspiring, but at the same time can be stressful as well. So we wanted to investigate how robotic coaching can help in such a setting. And we deployed 2 forms. We wanted to investigate how the effect of form would be in terms of these research questions. So the first one being, how does the form influence their perceptions of the robotic coach in the workplace? Then how the employees perceive the robotic coach's personality, and do the perceptions differ due to form? And then we have this, how the perceptions of the coach-coachee alliance. So this is quite important in a coaching sort of setup called working alliance, how those differ across these 2 forms. And then we paired with a company called Cambridge Consultants, and we designed a between subject study in their workplace. So we basically, 2 of my researchers camped in their offices for, I think, 6-7 weeks. So it was quite an intense one, running with multiple people, multiple forms and so on. So this is the QT robot. This is more humanoid form. Then we have the Misty robot that's more toy-like looking. Then we also designed a robotic coach personality. So this was done also in collaboration with the human coaches we have and human therapists that we collaborate. So for instance, the coach personality was designed such that it's high on openness, conscientiousness, but is medium on extroversion and agreeableness levels, and has low neuroticism. So for this, the ocean scheme was used. Then in terms of results, what we see is participants who interacted with the Misty robot, they scored the robotic coach warmth higher than the ones who interacted with the QT robot. So overall, we see in general, there's a bit more preference for the toy-like robot or toy-like looking robot. And we also see this being supported in the qualitative data because they were interviewed after the study as well. So overall, the findings show that the Misty robot was perceived more positively than the QT robot. So this could be surprising, but one of the things that I need to note here is the interaction was actually scripted. So we were not using ChatGPT and so on, which we now do in other studies. So it was autonomous, but at the same time prescripted in the sense that, you know, once the interaction starts, there was certain structure to the interaction in terms of what the robots could do or could say and so on. Then in terms of robot personality, again, we see actually that the Misty robot personality was perceived more in line with the target personality of this coach. And the interview results also support this, as you can see. So participants interacting with the QT robots did not even think that the robot had a personality, which is quite extreme. And overall, Misty robot personality was perceived more positively. And then in terms of alliance, basically our results show that participants who interacted with the Misty robot felt more bonded and able to achieve a goal than participants who interacted with the QT robot. Again, we see similar support from our interviews. So participants basically, and our results suggest that participants felt a stronger alliance with the Misty robot. So key takeaways from this is for using robotic mental well-being coaches in the wild, really the form matters in this specific context. It does impact the perceptions of behaviors, even personality. So even though it was similar, the same personality, the same sort of voice, the same way of talking, just the fact that the form was different impacted all of these things. So as the next thing, I'm going to try to run the video. Yeah, I think it's working. So similar study we ran in a cafe, in a public cafe, this time as a group mindfulness session. These were also deployed over 4 weeks. and there were different groups interacting with either of the robots.
Today, we'll be doing a mindfulness meditation session together, focusing on a body scan. Mindfulness is a faculty that everybody has, and through the meditation you can train it. It's a bit like going to the gym to train your mindfulness muscle. It's about paying attention in a particular way, on purpose, in the present moment, and non-judgmentally. Bring the mind back to the body with gentleness and firmness whenever you notice that it is wandered off. And notice the contact that the feet are making with the floor. Thank you for completing the first meditation and mindfulness session with me. I hope this was useful for you. We have 3 sessions left over the next 3 weeks. Before you leave, please take some time to fill in the survey on the tablet.
So you see, basically, this was in the sort of group setting, but we learned also from that humans thought that the robotic coach had multiple functions, so not only conducting mindfulness practices, but multiple functions of bringing the people together over the multiple weeks. So we discuss again some of this in the paper itself, but actually there's quite a lot of potential taking the robots out to a community center type of places. So now I want to look at this assessment aspect. Can the robots help actually in the evaluation of mental well-being? So not only promotion, this is what we looked at so far, but in terms of assessment of mental well-being. So our specific focus was with children. So this study we conducted with Department of Psychiatry with 2 professors who are experts in child or young people's health, and at the same time mental health assessment. And in this specific case, we're focusing on having robots as socially assistive robots to be able to engage them in this long-term and being more accessible and trying to provide this non-clinical context. Because what happens is children are reluctant to disclose their thoughts and feelings to adults, particularly, therapists are people they do not know, they're adults, they don't really have a close relationship with them. And at the same time, early assessment is really crucial for intervention because whatever they experience during childhood as difficulties in mental well-being is going to affect their whole lives. But the problem is current assessment techniques, the ones that are based on paper or even online surveys, have different limitations, so they're not engaging for children, might even create barriers of access, and it's difficult to extend them beyond the clinical context. So this is what we wanted to address with our work. So we wanted to investigate if and how robots can be used as novel tools for assessing mental well-being, whether they have potential. So we designed a study. So this was one-off. So they would come with their guardians to the lab, and then before the study, they and their parents would fill certain questionnaires that are commonly used in clinical practice as well. And once they come to the lab, they would have this 30 to 45-minute session with the robot doing different tasks. And I'll show you.
Oh, I am very excited to meet you. What is your name?
Hi, my name is Nicole.
So that's warm up. So initially when they arrive, that's the sort of things they do. Perhaps they do also fist bump or high five with the robot. Then it's a memory recall.
Okay, first, I would like to ask you if you could think of some nice thing that's happened to you in the last few days. Something that made you smile or happy. Can you please tell me about it?
Yeah, so I'm really happy because my best
Okay.
friend is coming visiting me this afternoon, and we are going to play together. So yeah, I'm really happy about that.
Then the
The
robot,
past 2 weeks, you
the
have
robot
felt
administers one of these questionnaires related to mental health assessment.
miserable or unhappy.
Not true.
And then they do a picture
So
task.
for our first picture, what do you think is happening in this picture?
So I think that there is a tiger that is chasing a monkey, and they are in a jungle. Maybe the tiger was just hungry and she wanted to eat the monkey.
So they do such things, and then what we do is, with the sort of guidance from our psychiatric collaborators, first of all, we divided the participants into 3 clusters or tertiles based on the total scores computed from the SMFQ that they did during the experiment session. And this corresponds to low, medium, and high tertile. So SMFQ provides a clinical cutoff point for depression sort of assessment in children. And high tertile means highly likely to get a diagnosis if they were to go to the clinical assessment. And then when we compare the ARCAT subscales in terms of self versus parent versus robotized modes of administration, we see that the robotized mode seems to be more successful in identifying these cases of well-being related anomalies. And this is followed by self-report. And interestingly, the parent report is the least one. So then what we see is a robot-administered mode actually helps with the anxiety, panic disorder, low mood subscales, and total score in terms of providing significantly higher for the higher tertile group. Then we observed that children of this higher tertile group responded also more negatively in the robotized mode in comparison with the other 2 modes. And responses to the robot also vary depending on their tertile. But overall, we see that the robotized mode highlights more the differences in cases of well-being related anomalies compared to these other modes of assessment. Then we took the picture-based task and also looked at audio analysis in terms of transcribing what they said, looking at nonverbal features. And our results show we do this leave one child out cross-validation, which is the most difficult one when we don't have any data from a specific child. We see there's variation. So, there's not a generic way of assessing, which might require some personalization. But overall, speech features are potentially good indicators for assessing children's mental well-being, but alone they're insufficient. So we really need to look at other multimodal aspects. And also this aspect of what personalized modeling would mean for mental well-being assessment is something that needs to be considered. Then we increased the sample size. We have been running other studies in this area. So overall, what we see, the findings don't change much. So we started with 28 children, but even when it increased to 41, and now we are running a longitudinal study, the results don't change much, but there are differences with respect to gender. Then now moving towards key takeaways. So we have done a scoping review in this area, and what we see is there are a lot of different challenges and things that need to be done in terms of using social robotics for the assessment, but also promotion of well-being. So the design features actually are quite important, including not only form, but different aspects. So these need to be really more clearly investigated. And we really need to focus more on creating autonomous robots and using data-driven approaches. But at the same time, also taking the studies from the lab to the real-world settings and doing studies with the real-world users. We also created these design guidelines, but I'm running out of time, so I'm going to skip this. If ethical aspects is something of a passion for you, you can look at this paper. So I'm going to quickly move on. And we ran various workshops in different conferences on this area, so using robots and human-robot interaction for well-being. And we also gathered lessons from like the community discussions. So for instance, ethics is really important, not only in terms of at the recruitment level, but also where the robots are being placed, how they're being used, whether they are being used to create bonds with people, and how that would cause damage when they're taken away from this setting. For instance, care homes is a good example where elderly are feeling isolated. So if they bond with a robot and these are taken away after the study, what that would mean. Then the idea would be not only making them promote well-being, but also social interaction, for instance, because they're physically embodied and physically present. In terms of, robot capabilities, that's different things that needs to be focused on. For instance, robots should recognize who the person is, should be able to understand all the conversations, which is tricky, of course, because children don't really speak up that much or move their mouth as pronouncedly as elderly do, so there are different needs there. And the robots should also be able to engage in conversations and adapt to the user, as we saw through the different studies I was showing. And then obviously other aspects like accessibility, engagement, and trust in terms of, people with different experience of, using technology, or what it would mean for different stakeholders. For instance, what it would mean for parents if children are starting to use robots for such assessments or even promotion of well-being. And then when we deploy them in the real world, how actually that would really mean in terms of translating them into beneficial tools for society. What does it really mean, and how we can ensure this happens despite some of the limitations as well. And we also have a special issue in the International Journal of Social Robotics. Some of the papers already are coming out. So embodied agents for well-being, if this is again something that you're focusing on, you will find some of this interesting. I will conclude here. So I was intending when I first provided the description to talk about bias and fairness as well, but there's just too much content. So if bias for well-being is something of interest to you, I would recommend you check out our Ishkai paper towards gender fairness for mental health prediction. And with that, I would like to thank my team throughout the years, focusing on different aspects. And I will leave you with what we do in my lab here in Cambridge, and I'm happy to take your questions. Thank you very much.
Thank you very much, Hatice. And